Hello, my name is Zach Gibbs, and I'm a content developer within education services inside Juniper Networks. And today we will be discussing the Configuring BFD for Static Routes Learning Byte. All right, so let's jump right to the example. In this example, we have a user that connects into VSRX1, and then VSRX1 connects to the internet using two different interfaces. And what we want to do is we want to configure the first interface, Gigi000, to be the primary interface, and Gigi003 to be the backup interface. And we want to do this with static routing. And so if Gigi000 fails, we want the traffic to fail over to Gigi003. And we can do that using BFD. And so what we need to do is we need to configure two static routes that are default static routes. So sends everything from the VSRX to the internet through a specific interface. And we want to have Gigi000 preferred over Gigi003. And then we want to configure BFD for the static default routes. And what we need to do here is, and notice I said routes as in plural because this has to be configured on both sides, on the VSRX and also on the ISP router, and I'll show you how to do that. And then with BFD, we want to configure a transmit interval of half a second, receive interval of 1/2 second, and we want failover to occur if two BFD hellos are missed. So that basically means we'll have up to 1 second of downtime. And then we'll examine the results and test the failover. So let's go ahead and jump right to the CLI. All right, so here is the CLI. We have VSRX1, we have the ISP, and we have the user. So let's go ahead and jump into configuration mode for VSRX1. And we're going to go to the routing options, static configuration hierarchy. And in here, we just have a static route configured for a local network that is reachable through a different router. And so we need to actually configure a default static route. And so what we need to do is we need to first, let's go ahead and edit under the default static route. And then we need to set qualified next hops. Now that first qualified next hop is going to be the next hop that is found through Gigi000. Remember, that needs to be our primary interface for all internet bound traffic. And so that's going to be 10.11.11.2. And we actually want to specify a preference value to that. We're going to specify 3, and then we're going to say qualified next hop. Now this is going to be the next interface, the Gigi003 interface. We're going to specify a preference of 7. So whenever the first route, the first qualified next hop is active, that's going to be the one that we want to use, or that the VSRX will use because of that lower preference. And then the next thing we need to set Vfd Liveliness Detection. And how this works is we need to set a transmit rate and a receive rate of half a second, which is 500 milliseconds. And then we need to have a failover if there's 2 missed hello packets with BFD. And so with the liveliness detection, we want to set the minimum interval to 500 milliseconds. That's half a second. And the thing to keep in mind here, you could set the transmit rate and the receive rate at 500 milliseconds, and it would do the same thing. But doing this in one command is always better than doing it in 2 commands. So we have that set. And now the other thing, the failover, by default, BFD will fail over to when there's 3 missed hello packets. And we need to set that to 2. So set BFD Liveliness Detection, and we set the multiplier to 2. And that should do it for us there. So let's go ahead and commit that configuration, and we'll jump to the ISP. All right, so here is the ISP. Basically the same thing, just with a little bit of a difference. Do have a little bit of static routes going on, but what we need to do is we need to configure a static route on this side with BFD that points towards the VSRX device for the BFD sessions to work properly. And so what we need to do here is there is a route or an IP address on VSRX1. I forgot to bring it up in our earlier discussion. I did have it on the topology map, but the loopback interface has the 10.1.1.1 IP address applied to it. And so that loopback address, we can set a static route on the ISP router to point towards that loopback address, and we can set up BFD with that static route, and that'll sync up with our BFD sessions that we just created on VSRX1. So let's go ahead and do that. Set route 10.1.1.1. Then we need to do qualify next hop because we need to match up what we have on the VSRX side. And the qualify next hop is going to be 10.11.11.1. And we're going to get that preference of 3. And then 10.12.12.1, preference of 7. And then we need to set the BFD liveliness parameters. Set that to half a second, which is 500 milliseconds. And then we need to set the multiplier to 2 as well. And let's commit that and see how this works. And there is one thing to point out here with the VSRX device, that this is a VSRX device. What I'm showing you here as far as configuration is just specific to any Junos device. But with VSRX, I did have to set under the host inbound traffic for the zone that has the GIGI 000 and GIGI 003 interfaces, had to set the host inbound traffic to allow the BFD protocol. So keep that in mind if you are doing this on an SRX. But I'm not showing that part because this is more specific to just generally how you do static route and BFD liveliness detection. Okay, so with that, let's go ahead and check out the BFD session. And perfect. This is what we want to see. We have 2 sessions up. We see the addresses. Those are the next hops. And we can see that we have a detect time of 1 second. That's great. Transmit interval of 500 milliseconds. Perfect. And a multiplier of 2. So how we come to the detect time is we take the transmit interval, multiply it by the multiplier, and we get 1. So 1 second. So if there's a failure, within 1 second, we will switch over to the other interface. So let's look at a few other things. Let's look at the route. You see the static route with a /3, that's the preference of 3, is preferred. So it creates basically 2 static routes, one with a preference of 3, one with a preference of 7. See the one with a preference of 3 is using the GIGI 000 interface. The one that has a preference of 7 is using GIGI 003. And so that's perfect. That's what we want to see. So let's jump to the user and start sending some traffic. Okay, we're sending traffic to an internet address. Let's go ahead and jump back to VSRX1. And we can see if we do the run show security flow session protocol ICMP command, we can see that we are using the GIGI 000 interface. It's coming in on GIGI 001, leaving on GIGI 000. Perfect. That's what we expect to see. So let's go ahead and bring down the interface that connects to GIGI 001 on the ISP router. And just to check, make sure about those interfaces, we can see that is GIGI 001. We'll just disable it and watch what happens. We can jump over to the user device and looks like we didn't drop any traffic. Perfect. So let's go to VSRX1, see what we're doing here. We can see that we are now using the GIGI 003 interface as the egress interface. Perfect. We look at the routing table. There's only one next hop. It's that interface, or it's the static route that uses the GIGI 003 interface. So that's our backup interface. That is being used right now. Perfect. Look at the BFD session. We see that first session is down. Second session is up. Perfect. That's what we want to see. So let's go ahead and see if it reverts back to the primary interface, GIGI 000, if we fix the problem. Okay, so we remove the disable tag. Let's click commit, and let's see if that session is up yet. Okay, session is up. Perfect. Again, it's up on this side. Awesome. And we can see that we are back to using the GIGI 000 interface, which is our primary. And we can see that we have both next hops in the table for that default route, and the primary for the next hop is using the GIGI 000 interface. So that brings us to the end of this learning byte. We discussed how to configure BFD for static routes in the CLI, and then we demonstrated how to verify BFD for static routes. So as always, thanks for watching.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses, learning paths, industry segment and technology-specific training paths, Juniper Network's certification program, the ultimate demonstration of your competence, and the training community. From forums to social media, join the discussion.